Look up at the night sky. It's a vast, seemingly infinite expanse filled with countless stars, each one a distant sun, twinkling like tiny diamonds scattered across a velvet canvas. Every twinkling point of light represents a distant sun, a star much like our own. These stars have been the subject of human wonder and scientific inquiry for centuries. But what if I told you that the most common type of star in our galaxy is invisible to the naked eye? These stars, hidden from our view, are far more numerous than the bright stars we see. These hidden giants are red dwarfs, and they outnumber stars like our Sun by a staggering margin. Red dwarfs are the silent majority of the stellar population, quietly dominating the galaxy. Red dwarfs are everywhere, making up a staggering 85% of the stars in the Milky Way. Imagine that for every bright star you see, there are many more red dwarfs lurking in the shadows. These stellar neighbors are far smaller and cooler than our Sun, emitting a faint reddish glow that belies their true significance. Their size and temperature make them difficult to detect without the aid of powerful telescopes. Despite their dimness, red dwarfs hold the key to answering one of astronomy's most profound questions. Are we alone in the universe? Many red dwarfs have planets orbiting them, some of which may lie in the habitable zone, where conditions could support life. These planets, known as exoplanets, are of great interest to scientists. The sheer number of red dwarfs means there could be countless worlds where life might exist, waiting to be discovered. With advancements in technology, astronomers are now able to study these elusive stars and their planets in greater detail. Observatories around the world are on a quest to uncover the secrets of red dwarfs and their potential to host life. The exploration of red dwarfs and their planets is not just a scientific endeavor. It is a journey that could redefine our understanding of the universe and our place within it. As we continue to gaze up at the night sky, we are reminded that the answers to our biggest questions may lie in the faintest of stars. Red dwarfs are the cosmic underdogs, much smaller and cooler than our Sun. These stars, often overlooked, play a crucial role in the galaxy's ecosystem. Despite their diminutive size, they are the most common type of star in the Milky Way, making up about 70% of all stars. They are like embers compared to our Sun's roaring bonfire. This comparison highlights their subtle yet persistent presence in the cosmos. While they may not shine as brightly, their longevity is unmatched. While our Sun boasts a surface temperature of around 5,500 degrees Celsius, it burns through its fuel relatively quickly in astronomical terms. Red dwarfs barely reach half that, with surface temperatures of 2,000 to 3,500 degrees Celsius. This cooler temperature allows them to burn their fuel much more slowly, granting them lifespans that can stretch into the trillions of years. This difference in temperature directly translates to their color and brightness. The cooler the star, the redder and dimmer it appears. This is why red dwarfs have a distinct reddish hue and a faint glow. Our Sun, a yellow dwarf, blazes with radiant energy, providing the necessary warmth and light to sustain life on Earth. Its intense energy output is a double-edged sword, as it also means a shorter lifespan. Red dwarfs, in contrast, emit a much fainter reddish light, more akin to a distant ember than a raging inferno. Their steady, prolonged burn makes them fascinating subjects of study, as they could potentially host planets with conditions suitable for life over incredibly long periods. The habitable zone, often dubbed the Goldilocks zone, is the region around a star where temperatures are just right for liquid water to exist on the surface of a planet. Too close and water boils away. Too far and it freezes solid. For life as we know it, liquid water is essential. Red dwarfs, due to their lower temperatures, have a much closer inhabitable zone compared to our Sun. Planets within this zone would experience a significantly different relationship with their star. One of the most intriguing consequences of a close inhabitable zone around a red dwarf is the phenomenon of tidal locking. This occurs when a planet's rotation period matches its orbital period, causing one side to permanently face the star, while the other remains shrouded in perpetual darkness. Imagine a world where the sun never sets on one side and never rises on the other. Such a scenario would lead to extreme temperature differences between the two hemispheres, potentially creating wildly different environments and weather patterns. Stellar fury, the threat of red dwarf flares. Red dwarfs, while seemingly calm and dim, are prone to violent outbursts known as stellar flares. These sudden releases of energy are far more powerful than anything our sun produces and can bathe orbiting planets in intense radiation. These flares pose a significant challenge to the potential for life around red dwarfs. Frequent and powerful flares could strip away a planet's atmosphere, leaving its surface exposed to the harsh radiation of space. The habitability of planets around red dwarfs hinges on the frequency and intensity of these flares. Life finds a way, adapting to red dwarf environments. Despite the challenges, life is remarkably resilient and adaptable. On Earth, we find organisms thriving in seemingly inhospitable environments, from the depths of the ocean to the driest deserts. It's not unreasonable to imagine life finding a way to flourish, even in the face of tidal locking and stellar flares. Imagine creatures with reflective skin on the star-facing side, protecting them from the intense heat and radiation. Or perhaps life could evolve in the twilight zone between perpetual day and night, where temperatures might be more moderate. Endurance of the diminutive suns, a boon for life. Red dwarfs have one crucial advantage over stars like our sun: their extraordinary lifespans. These small, cool stars burn their fuel so slowly that they can outlive most other types of stars by a significant margin. While our sun will burn for roughly 10 billion years, providing a stable environment for life for only a fraction of that time, red dwarfs can continue to shine for trillions of years. This means that planets orbiting red dwarfs have a much longer window of opportunity for life to develop and thrive. This incredible longevity provides ample time for life to emerge and evolve on planets orbiting these stars. Imagine a world where life has billions of years to adapt, change, and grow, potentially leading to forms of life that are far more advanced and diverse than anything we can currently imagine. Imagine civilizations rising and falling, each leaving behind a legacy of knowledge and culture, technological advancements beyond our wildest dreams, with societies that have had eons to perfect their understanding of the universe and their place within it, all unfolding over billions or even trillions of years. The sheer timescale involved allows for a depth of history and progress that is difficult for us to fully comprehend. The extended lifespan of red dwarfs offers a tantalizing glimpse into the vast possibilities of life in the universe. It challenges us to think beyond our own solar system and consider the myriad ways life might flourish under different conditions, in environments that are both familiar and utterly alien. Life on Earth relies heavily on photosynthesis, the process by which plants convert sunlight into energy. But what happens when the light source is significantly different? Red dwarf stars emit most of their light in the red and infrared wavelengths, unlike our sun's yellow light. This difference in light spectrum poses a fascinating question. Could photosynthesis occur under the predominantly red light of a red dwarf star? If so, what would this mean for the types of plants and ecosystems that could arise on such a world? Red dwarf stars present a fascinating paradox in the search for life beyond Earth. They offer the promise of stability and longevity, providing ample time for life to emerge and evolve. However, they also present significant challenges, from tidal locking and extreme temperature differences to the threat of powerful stellar flares. The red dwarf dilemma lies in balancing these factors. Can life truly thrive in the face of such challenges? The search for life around red dwarf stars is one of the most exciting frontiers in modern astronomy. Powerful telescopes, both on the ground and in space, are scanning the cosmos, searching for telltale signs of planets orbiting these dim stars. The discovery of a planet in the habitable zone of a red dwarf star would be a monumental event. It would ignite our imaginations and fuel the quest to understand if we are truly alone in the vast expanse of the universe. Red dwarf stars, despite their diminutive size and dim glow, hold the potential to revolutionize our understanding of life in the universe. They challenge our preconceived notions of habitable zones and force us to imagine life forms that could thrive in conditions vastly different from our own. As we continue to explore the cosmos, red dwarf stars will undoubtedly play a central role in our quest to answer the age-old question: are we alone? The answers we find may surprise us, revealing a universe teeming with life in its most unexpected forms.